Welcome to Data Science with EJD. In this video, we start with unsupervised learning with an introduction, and it's about understanding learning without labels. Just like I had said previously, that supervised learning is, involves data with labels, where you have features and targets and things like that. But for unsupervised learning, you're working with data without labels per se. Okay, so having said that, we'll be looking at what supervised learning is, we'll see some real world applications, its benefits and challenges, and then the conclusion. So, what is supervised learning? That's our first question. What is unsupervised learning? What is unsupervised learning? Unsupervised learning refers to the class of machine learning algorithms used to draw inferences from data sets consisting of input data without labeled responses. All right, so we don't have labeled, like maybe this is row one, row two, or things like that. But here it's just the data without label. So the goal is to discover hidden patterns, groupings, or structure in data without explicit labels. Okay, so here this is something from the Google page, where we have this is a bit faint. Of symptoms, but average number of symptoms per week or something like that. And we have average something like it's not quite clear right now. Okay, so this is the data unlabeled, so it's not like this is row, this column, that. But then after it has been clustered, then you now see that, oh, we have this yellow cluster, the green cluster, and the red cluster. So it's like at the end of the day, you have this unlabeled data, and then you can group them based on certain criteria. So that's the idea of unlabeled data and unsupervised learning. So as a refresher, right? Let's look at the let's contrast and compare supervised versus unsupervised learning. So of course, for supervised learning, you have label data, you have X, which are the features, and you have Y, which is the targets. But in unsupervised learning, you only have input data. Of course, the features or the features are the input data, while the Y is output data. But in this case, you only have the input data X. Then in supervised learning, you predict outcomes because based going by the targets or the outputs. But for unsupervised learning, you only discover patterns basically, right? And examples of supervised learning will be things like detecting if a particular message is spam or not. So if spam detection, that falls under classification, and then you have house price prediction, which falls under regression, because supervised learning is basically categorized into classification and regression algorithms. So for unsupervised learning, you can have things like customer segmentation, anomaly detection, because under supervised learning, you have things like clustering. Okay, I guess we're going to get there, right? Yeah, you have things like clustering, dimensionality reduction, and things like that. So let's look at some real world applications. So we have clustering and segmentation. That's one application of unsupervised learning. So you want to group similar data points into clusters. That's the idea of clustering. And the use cases includes in marketing, customer segmentation. Maybe you want to group customers that buy a particular kind of product or customers of the say of a particular age into a cluster. Then in biology, you have it in things like gene expression grouping. And for vision, you can have it for image segmentation. Then you have popular algorithms for clustering like k-means, hierarchical clustering, and I think density-based scan or something like that. We're going to see all of this one after the other. So then we have dimensionality reduction. That's another thing that you can have under unsupervised learning. So you have you have what we just saw up there, clustering and segmentation, and then you can have dimensionality reduction and compression. So the goal here is to reduce data complexity while preserving key information. So when you have complex data, it's difficult to work with, but if you can reduce the dimension without losing key information, then it's a very nice thing to do. So applications include visualizing high dimensional data. Like if you have a 1000 dimensional data, you can now view it in 2 dimensions without losing key information. And this is useful in image compression, for instance. So key techniques under dimensionality reduction are things like PCA. PCA is principal component analysis. Then you have TSNE, autoencoders. So you have that. Okay, Then you can also do something like anomaly detection as a real world application. So the goal for anomaly detection is to identify rare or unusual data points. Applications include credit card fraud detection, intrusion detection in networks, equipment failure prediction. Methods include isolation forest, one class, support vector machine, Gaussian mixture models, and things like that. Okay. So what are some benefits and challenges of unsupervised learning? So first of all, why unsupervised learning, right? Unsupervised learning enables learning from unlabeled data. So you don't need to classify the data into targets and targets and feature, right? It's not necessary. You just have the data the way it is, and then you want to see patterns. And you can discover unknown structures in data, and it is useful in data exploration and pre-processing. So it forms foundation for more advanced techniques, e.g., semi-supervised and self-supervised learning. So some challenges: no ground truth for evaluation. Results may be harder to interpret. Performance can vary widely by algorithm and data. Choosing the number of clusters or dimensions often requires heuristics. So, if in clustering, for instance, how many clusters should you choose to get the best results? So that can be a really serious challenge. So in conclusion, unsupervised learning helps uncover structure in unlabeled data. It is useful for clustering, compression, and anomaly detection. While powerful, it requires care in evaluation and interpretation. So for the next steps, you need to explore core algorithms like k-means, principal component analysis, TSNE, autoencoders, practice with real-world datasets. Now, in the next set of videos, I'm going to take these algorithms one after the other and run through them. To be a part of this experience, don't forget to subscribe to my YouTube channel. By clicking this, you can go straight to my channel. So you have my channel here, with all the, so you see all the videos all along. Then to actually do some kind of arrangement, I have everything grouped into playlists. So you can actually pick one and then go through like that. So the current playlist, we already have 30 videos. So data science with EJD. So you click on this, then you can follow the videos one after the other. So even if you're just coming in, you can catch up with the things we've done previously. So there are other playlists, uh, you know, the other playlists like SQL with Python, data analysis with Python, and some mathematics playlists like that. So we have all of this going on here. Then I also get to talk about jobs, scholarships. That's what you find under AJD interviews. If you're interested in Bible talks, I also do some Bible talks sometimes. So, and then we have personal development programs where we discuss different aspects of development, of personal development. So, we want to explore the playlist for sure so you can get the best. Then, of course, I now have channel membership so you can explore. So if you want to get special benefits from my channel, you can become a member and you get special privilege. So you want to explore these three levels of membership: AJD bronze access, silver access, and of course gold access. So with their different level of benefits. All right. So with this, I come to the end of this video on the introduction to unsupervised learning, which deals with unlabeled data, which deals with machine learning that is related to unlabeled data that doesn't have targets and features like we have for supervised learning, but it's just data where you can discover pattern and things like that. So thank you so much for listening. If you have not subscribed to the channel, of course, you want to go ahead and do that right away and hit the notification bell so you can always get alerted each time a new video is released. For those who have subscribed, thank you so much for doing that. Let me know if there's something you'd like me to try out. Let me know how helpful this video is for you. Also, of course, I've told you you can explore being a member to get some special privileges if you want. Or if all you do is subscribe, you are also good to go. Then be sure to like and share so that more people can have access to the great content I have going on here. So like come your way again, keep doing data right. Bye.